All right, so today we're going to talk about the law of cosines, law of sines. And opening a smart notebook here, all right, so I'm going to ask you guys, if you will, to remember back in the day when you were in geometry, and we had some congruence theorems when we were proving that triangles were congruent to each other, and they were acronyms. And so this first triangle looks like a what case? Side angle, side, right. So this would be a side angle side case. The one to the right here clearly is side, side, side. Angle, angle, side, yes. Uh-oh. This is awkward because we may have told you before that this just doesn't exist. But this is the angle side, side case. And yes, I'm going to use that word out loud, but we'll talk about that in a second. And there's another form of this case when they were being polite. This would be the hypotenuse leg, the HL postulate. I don't know if you remember that postulate. I know that was a long time ago, but anyway. So why do we need the law of sines? Well, then my question would be, are all triangles right triangles in this universe? No, sadly not. And so the answer to this is going to be no. We don't all have. We're going to say some are oblique. And what does oblique mean? Non-right. And they need to be solved as well. All right, so let's consider, I'm going to just motivate the lesson here really quickly. So these are the kind of problems we would be solving. A pole tilts towards the sun at an 8-degree angle from the vertical. So we'll imagine that we have a flagpole, right? And our stars and stripes. Bless you. And it's 8 degrees from the vertical. So what would that angle be with the ground then? $98. So this angle here would be 98 degrees because this is 8 degrees from the vertical. And casts a 22-foot shadow. Well, what causes a shadow is the big sun in the sky. And the shadow is going to be on the ground. And they're telling us it's a 22-foot shadow. So this is going to be 22 feet. And they're telling me the angle of elevation is 43 degrees from the ground. How tall is the flagpole? Well, what case would this be? Where's our information? Angle? Angle, side, angle. This would be an angle, side, angle case. And we can use the law of sines in order to solve that. And when we did the law of sines in the explorations a minute ago, what did we say the law of sines was? We said it was the sine of angle A over little a equals the sine of angle B over little b equals the sine of C over little c. And you don't have to be a right triangle to use this. Now we're limited with right triangles because we can use Pythagoras, a squared plus b squared equals c squared. And we can use SOHCAHTOA, but can we use SOHCAHTOA on and Pythagoras on triangles that are not right? The answer is no. So obliques need some special attention, and the law of sines does that. So we're going to talk about the law of sines applies to oblique triangles with these characteristics. This is what I mean by characteristics is that your information is on an angle side, or an angle side angle, or an angle little side big side, or an angle big side little side. Okay. So let's draw an angle side or angle side triangle. It would just be, I would know this angle, and then I'd know this side. That's where my information would be. Angle side angle, we just did the flagpole one, didn't we? Where we know this angle, this included side, and that angle. Now, this next one, I have the S in the middle here is a little s, which means that's the shorter side. So I can have an angle with a short side and then a longer side. So I have an angle, short side, longer side. And I call this one a little ass problem. And yes, we can giggle. We have to make law of sines fun, right? And that's because the little side is in the middle, and this problem isn't much of a problem. And then we get to the big ass problem, which is what we call the ambiguous case. And that's where I have an angle with a longer side and then a shorter side. Angle, big side, and then a little side. Where the big side is in the middle of your information. Okay, so these are the cases we can use it for. Law of sines. We say angle, side, angle, little ass problem, and a big ass problem, okay? All right, so why do we call it ambiguous? Well, I looked up what ambiguous was on the World Wide Web. And able to be understood in more than one way, having more than one possible meaning. So, the big ass problem is ambiguous because we can have 0 triangles, 1 triangle, or 2 possibilities. All right. And so I'm going to say that angle A I'm given and angle B is the large side because I made it really long here. Okay. And we can have the case where we have 1 triangle, and that's where I have the perpendicular. So I'm going to drop the perpendicular down from C. And that's only 1 possibility. And don't mind this extended line. I just have it there so that I could create a triangle with it. So this would be the 1 triangle solution. Then we could have a situation where the information that we're given this angle, and then we have a side that we're given that's the long side, and then we could have a short side here that is too short to reach. So how many triangles will that form? 0. So this one forms 0 triangles. That means the side is too short to even reach to create a triangle. And I call that the dangler. the side is angling. And then we can have the possibility where we create two triangles. Here we go. I'm going to draw this side right here, see, like this. And obviously it's long enough to reach, but it's not perpendicular. But I could have drawn it. I could have drawn it with the same length. Oops. Over here, couldn't I have? So what are the two triangle possibilities? Well, I could have had this big, large triangle as a possible triangle with the given information, or I could have had the skinnier triangle as a possibility, right? So I had two possible cases with side length of that length. So this is the true triangle possibility. So the possibilities are zero triangles if I have a side that I'm given that's too short. I have the possibility where I have one triangle when it's just long enough to reach, and that's the perpendicular solution. Or with the given information, I could have possibility of two triangles. And that's why this case, the big ass case, is ambiguous. Does that make sense? And you don't know what you have until you get into the problem and solve it. Yes, sir.
Don't you have two of the sides so you
know?
No. But it's,
oh, yes, you're given two of the sides, yes. And you're given an angle and the two sides, but you don't know what the other angles are. Right. All right, but we're going to do some examples. All right? Which one's the big ambiguous case? The big ass, right? Ambiguous, big ass problem. And that's when the included side is the largest side. We remember what included means, right? All right, so this one says solve the triangle. We have 102.3 degrees, 28.7 degrees, and little b is 27.4. Now we're going to use the same convention that we did with the right triangle. So little side C is opposite angle C and vice versa, right? Okay, so let's just draw it. Now I'm going to draw an angle here that's 102 roughly. It doesn't have to be exact. So there's C. And I know angle B I'll put up here, and then this is angle A. So this is little side C, which I don't know. This is 102.3 degrees. Little b, angle B is 28.7 degrees. And they're telling me that little b is, which is across from here, 27.4. Now, when I say to solve, or I ask you guys to solve a triangle, that means I want all of the rest of the pieces that we weren't given. So what are we solving for here? I need angle A, and I do a little chart over here so that I make sure I got them all in one place. I need little a and little c. All right. Now I know right away that this is oblique because there's no way this other angle could be what? 90 degrees? Because they must all sum to 180. So I write the law of sines with my given information. So the sine of A, do I know angle A? I mean I could find out really quickly, but I wasn't given that. So over little side A, I wasn't given little side A, equals the sine of B, which is 28.7 degrees, over little b. Oh, I was given little b, right, which is 27.4, equals the sine of C, which I was given 102.3 degrees, over little side C. Now, I affectionately call one of these ratios the go-to ratio. That means I have all the given information that completes it. So which one of these is going to be our go-to ratio? B. So this is my go-to ratio. And then I do the very first, I equate the go-to ratio to the other ratio that has only one piece of information missing, which is the little side C. All right, so we're going to do that. We're going to say then sine of 28.7 degrees over 27.4 equals the sine of 102.3 degrees over little side C. I'm going to cross multiply and get little side C times the sine of 28.7 degrees equals 27.4 times the sine of 102.3 degrees. Now, I don't put anything in the calculator until the very end because then I don't have any rounding issues. All right, and then to solve for little side C, what do we have to do? Divide both sides by the sine of 28.7 degrees. So this is going to be 27.4 sine of 102.3 degrees over the sine of 28.7 degrees. So can you tell me what that is?
55.75.
Say it again.
55.75.
55.75. It's pretty long. But I would expect C to be longer. 55.75?
Yes.
All right, now, angle A is going to be really easy to find because I know it's the other two angles. It's going to be 180 minus 102.3 and 28.7, which is? What? 49?
Yeah. What?
Oh, nothing. Okay. Remember, I'm sick, so my hearing is down. So it's going to be an interesting day. Now I need little side A. What do? I go back to my go-to ratio, and then I'm going to solve for little side A. So my go-to ratio was sine of 28.7 degrees over 27.4 equals the sine of 49 degrees over little side A. Cross multiplying, we're going to get A sine of 28.7 degrees equals 27.4 times the sine of 49 degrees. Little side A equals 27.4 sine of 49 degrees all over sine of 28.7 degrees. And what do we get? 43.06. Now, triangles are a lot like Goldilocks and the Three Bears. The Papa Bear angle, which is the largest angle, is going to be across from the largest side. The Baby Bear angle is going to be across from the baby side, baby length side, and the Mama Bear angle is going to be across from the Mama Bear side. And I know that sounds like kindergarten or whatever, but I like to, when we're all done, check to see if we're all right. So is the largest side across from the largest angle?
Yep.
And that's good news. And then the middle one would be 49 degrees, which is A. Is that across from? Yeah, it worked out, didn't it? So you know that you're in a good spot. All right, moving right along. Well, what kind of triangle was this? This was angle, angle, side. I like to write that down. And so for angle, angle, side, you're either going to have a triangle or you're not. There's no ambiguity about it. All right, let's draw this one. C is 65 degrees, so there is angle C. I'm going to make it 65 degrees. Little side C, or the side of opposite, is 44. B, it doesn't matter where you put B. I'll put it in the same place you do. Where do you want to put it, above or below? Above? below, okay, or below. So we'll put it below, so that's going to be, this is 32 here. So the included side here is, we have angle, little side, big side, right? So this is a little ass problem. So it's not ambiguous. All right, but we're going to set up the law of sine. Now, what do we need to find here? This is A. We need angle A. What else do we need? Angle B. And little side A. All right, so we set up the law of sines with the information we were given. We get the sine of A over little a equals the sine of B over 32 equals the sine of 65 degrees over 44. What's my go-to ratio? It's a C ratio, you're right. And we're going to solve for what first? Sine of B, good. So we're going to say that the sine of 65 degrees over 44 equals the sine of B over 32. Cross multiplying, we're going to get 44 times the sine of B is equal to 32 times the sine of 65. Sine of B is equal to 32 sine of 65 degrees over 44. So can somebody tell me what this number is on the right? You know, just what this fraction is. What? I just want to know what the number is, you know, like
0.659.
0.659. That's nice. It's not bigger than 1, is it? So that's good news. So the sine is positive in what two quadrants? 1 and 2. All right. So we need to find alpha. 41.23 degrees, okay? So B could be 41.23 degrees, or what could be also be? 180 minus alpha, which is 138 point. Now, what angle were we given? We were given A is 65. What happens if I add 65 to 138.77? Have we busted through the 180 degree threshold? So this angle is not going to be a solution. That's nice. That's why this case is not ambiguous. What will happen with the big ass problem is your angle will be the acute case, and then we know what acute means, right? Less than 90. And then your obtuse case will be just big enough that you'll be able to have another possibility. Okay? So if little b, or your angle B is 41.23, let's put that up there. 41 point. Now, we could use another ratio to solve for A, but should we? We should just do 180 minus 41.23 minus 65, and you get 73.77 degrees. Thank you very much. And now we have one step left. We have to solve for little side A. Now, we're going to say the sine of, what's our go-to? We always go back to the go-to ratio, which is going to be the sine of 65 over 44 equals the sine of A, which we said was 73 point, what was it? 73.77 degrees over little side A. Cross multiplying, we get little side A times the sine of 65 degrees equals 44 times the sine of 73.77 degrees. Little side A is equal to 44 times the sine of 73.77 degrees, all over sine of 65 degrees. So little a is 46.61. Now, does that make sense with our picture? Yep, I agree. Questions on little ass problems? All right, here we go. Let's draw this one. 20 degrees. It's pretty small. And I don't necessarily do them to scale, but you know. Little side A is 12. What am I nervous of this moment? And I'm going to put B down here.
Big ass problem.
Right, because the included side, now when I say included, I said angle, big side, little side. The included side meets the side in the middle. This is a big ass problem. So what are my possibilities? Zero triangle, one or two triangles. So the minute I realize that I have a big ass problem, I do this to spur myself into remembering that I might have two solutions. Okay? And the first triangle you're going to get if it's a big ass problem is an acute case. Now, what do I mean by that? The first angle you find will be acute. And the second angle will be obtuse. It'll be 180 minus your alpha. All right, so we're not going to let this big ass problem scare us. We're going to just set up the law of sines, which is going to be sine of 20.5, good, over 12 equals sine of B over 31 equals the sine of C over little side c. So what's my go-to ratio here? A, nice. So we're going to start with our go-to ratio and solve for angle B. So we're going to say the sine of 20.5 degrees over 12 equals the sine of B over 31. Cross multiplying, we get 12 times the sine of B equals 31 times the sine of 20.5 degrees. And then sine of B is equal to 31. Whoops, let's write it better. 31 times the sine of 20.5 over 12. Now somebody's going to tell me what this number is.
0.9047.
Is it really? 31 times that, and it's, say it again? Okay. So, what quadrants? 1 and 2. Got to find out what alpha is. Alpha here is the inverse sine of 0.90, blah, 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 blah. 64.78 degrees. So, B1 is going to be 64.78 degrees. What's the other possibility?
115.22.
Now, does that work with the 20.5, both of those cases? Okay, so what are we going to do with these two numbers? We're going to take them and we're going to put them in our little chart. So B1 is going to be 64.78. And then you said B2 was 115.22. Now, what is C1 going to be? That's going to be the angle that goes with 20.5 and 64.78. So we go 180 minus 20.5 minus 64.78. 94.72 degrees. And then what's going to be the angle C2 here that goes along with the 20.5 and the 115.22? 44.28. So I got two triangles going here. So little side C is going to be, I'm going to have a little side C1 and a little side C2. Right?
Yes.
So what's going on with this triangle visually? This 12, I drew it this way, but where else could I have drawn it? This way, couldn't I have? I could have. And so this angle here is the 64.78. And what's this angle here, this obtuse case? The 115.22. So those are the two possibilities. Now, how do I find little c1? I go back to my go-to ratio, and then I use the c1 angle to find the little c1. Does that make sense? We're going to have to do how many times? Twice. So this is going to be the sine of 20.5 degrees over 12 equals the sine of 94. Try again, 94.72 over little c1. So we're getting to the point now where we could just say c1 equals, it's going to be these two multiplied divided by,
34.15.
hold on a minute. I got to write this down for future. This is times, 12. Divided by sine of 20.5. And what do you get?
34.15.
34.15. Now, based on my picture, do I expect little side C2 to be bigger or smaller? Smaller. So I'm going to do the same calculation, except now I'm going to use 44.28. So we're going to say sine of 20.5 degrees over 12 equals the sine of 44.28 degrees over little side C2. Little side C2 is going to be 12 times the sine of 44.28 degrees over sine of 20.5 degrees. And what do we get for little C2? 23.92. Okay? So that's all there is to a big ass problem. Now, why is it a big ass problem? Because it takes us
Yes.
the gas time, right? That's right, because we have the possibility of two triangles, but sometimes big ass problems turn out to be a lot easier than that. So let's do 85 here. Yeah. So let's see if this one is. So little side A is 15. And what would that case be? That would be the dangler, right? Where that little side A isn't long enough to reach. And this B is 25. And I'm going to put C here, little side C. So first of all, we have to decide, is this a big ass problem? Is the big side included? We have angle, big side, little side. So this is a big ass problem. So I'm immediately going to do this just in anticipation of, I might have two triangles. First case is going to be the acute. The second case will be the obtuse. So we're going to set up our law of sine. Sine of 85 degrees over 15 equals the sine of B over 25 equals the sine of C over little c. We're going to go to our go-to ratio, which is the sine of 85 over 15, and we're going to solve for sine of 85 degrees over 15 equals the sine of B over 25. And can we go directly to the sine of B equals 25 times the sine of 85 degrees over 15. Now what is this number? What is it? 1.66. What do we know right away? Can the sine of b equal a number that big? Now, let's see what happens on your calculator when you do the inverse sine. That's what you see when we have how many triangles as a possibility? 0. This means, what did we get? We got domain error. On the calculator, it is not enough to write domain error. What do you have to say? Therefore, no possible triangles. Now, why are there no possible triangles? What's happening in this picture? This side didn't do what? Didn't make it. Okay? So this one is a big ass problem that turned out to be really easy. Now, the question has always been, when will I know that I have no solutions? Guess what? The very first time you solve for that angle, you're going to know. You know right away. Yeah. All right. So moving right along. What is this one? This one is a, whoops, helps if I have some ink. I'm just going to set this one up. It is, but what are you guessing with the C being closer in length here? What are you thinking? Then we're going to probably have 2 triangles. And you agree that this is a big ass problem, right? So I set it up. I've got a minute. Let me set up the next one. This one will have 2 solutions, and I'll have a complete set of notes online. This one is another big one, okay? And that's it, right? All right, so the homework's just going to be you guys solving triangles with the law of sine. All right?
Where is it? The book?
Yes, it's in the book.